In this exercise, we want to prove that the function 3x is continuous at the point a is 2. If we sketch the graph, then 3x looks like that. At some point a is 2, here's the function value. And if we want the function values to fall into this interval, 2 results in 6. So we have the interval from 6 minus epsilon up to 6 plus epsilon. So if we use this information, this line turns into x minus 2 less than delta should imply f of x, which is 3x, minus f of a, which is 6, should be less than epsilon. But here we can factor out 3, and we can divide by 3, and we have x minus 2 in absolute value is less than epsilon third. So we want to find the absolute value first. We want to find delta such that if x is close to 2, not more than delta, and then this is true, meaning not more than epsilon 3. So the natural choice is delta is epsilon divided by 3. You see, 3 is the slope. This is the coefficient at which all the changes of x are magnified into changes of y. If the change of x is not more than epsilon divided by 3, then after this magnification by 3, by the slope of the function, the change will be, or the function value will be not more than epsilon. The steeper the graph, the higher the slope, the higher this coefficient. But if the steepness is bounded, then if we divide epsilon by the largest positive coefficient, later we will see that this has the meaning of the derivative. If we divide by this coefficient, then such delta is good. Is this the only delta that works for the definition to show that the function is continuous? No. If you take lower delta, it's also good. Because if you take lower delta, you shrink this interval, and if the values resulted in, if this x values resulted in function values here, then if you make this smaller, it will be smaller, but it will be still in the interval. So we can say that any delta not more than epsilon third will do, and we want delta to be positive. So this is to prove that the function 3x is indeed continuous at the point a is 2.